Okay, right now we're gonna do a problem using the plus transform, actually using for unit step function problem. So as you can see, I plot this 0 to 1, and then it goes to 1, and then drops back down to 3, and then the 4. So obviously this function is t minus 1, and 3 minus t um, uh, is given. So now the first step is here is to set up the boundaries. So you have 0 as a starting point, and then we go to 0 to t minus 1. I'm sorry, 0 to t less than equal to 1, and then it goes all the way down as you could see here. Um, so after doing this bounded, we need to write g of t function. So then we could take the Laplace transform, and that will give us the solution using the step function. So the step two, after finishing this, step two is using the first one. So what we do is g of t um, is the function starting point, which is 0, and then we go and we see the bounded here, and we have t minus 1, right, the second function. So we take the second function value, t minus 1, and multiply by u, and then let me go back. Actually, I did a mistake here. So t minus 1 minus the original function, the original value. So we take the second, t minus 1 is the second. Let me write it down here. So this is second function. And this is the first g of t. And this is second g of t. So this is the second g of t, and this is the first. So this is the first one minus this second one minus the original one, and then you multiply it by um, u t minus 1. What is t minus 1? Well, t minus 1 t minus 1 is the bound limit of the first one. So if you get this, you basically got the pattern. So again, let me do a quick review. So like we said, t minus 1 is the second function minus 0 times it by u. T minus 1 is the bounded of the first one. Okay, now we got the g of x. So what you do when you find the second one, you just carry it over. So this will simplify to be um, t minus 1 u t minus 1. So now g of t of the second one. So before actually starting this, I forgot to mention one important thing. So in here, what was g of t here? G of t is equal to 0, and then the t is 1. What is the t of 1? T of 1 came um, from here. T of 1 came from here. So now the same theory applies here as well. So t minus t g of t at 1. So g of t of t minus 1 so t minus 1, okay, and then t is equal to 2, and 2, as you could see, came from here. So t minus 1. Okay, now let's bring the formula that we actually solved already down. So t minus 1, just carry it down. U t minus 1, okay, plus, now what we have, t minus 1, what is our second function? It's 3 minus t, right? So 3 minus t in parentheses minus, okay, minus t minus 1. And this is the function of the second one, right? And this is a minus. It's always minus. It's always minus. Let me make it a little thick. It's not quite readable. So t minus 1 minus t minus 1, uh, and then that should give us, what are we looking for? So 3 minus 1 minus t minus 1, and you multiply it by, let's see here, u, and t minus 2 is the other bound that we have. Okay, now let me change color. Okay, so we got this far. So now we need to move on and do the next one. So actually we could simplify this. So 3 minus t minus 1, or actually plus 1. So u t minus 2. So now this become 3 minus 2t plus 1 u t minus 2, and we keeping all of this. This is just carries down. I don't want to just keep rewriting again, because they're gonna be too messy and takes too long. um, just continue writing. So now we could just factor this out, because at the end you find out what's the benefit of it. We always want it to be t minus 1, because t minus 1, t minus a, this is an a value. So in order to make it our life a lot easier, we always wanted to keep in this pattern. So at the end, when you take the Laplace transfer, it will be a lot simpler, and it will be a lot easier uh, to find the Laplace transfer. So let's factor negative 2 out. So you get negative 2, um, 2 minus t, okay? And actually, take it back. This becomes t minus 2 u t minus 2. So negative 2 t minus 2 u t minus 2. So this is the second one. Now we need to do the third one. So let me get another page. Okay, now this is another page. I started again. So g of t, this is the third one. So 3 minus t, t equals 3. So g of t is equal to t minus 1, okay, u t minus 1. This is I'm bringing up all the ones we already did. So I can just write it once, and I'm not gonna write it again. So in case you don't see me write it again, because that's the reason I don't want to keep writing again and again. So this all what we already solved, and we get this part. So we got to 1 plus, this is the first one, this is the second one, okay? And we're gonna do the third one now. So the third one will be plus, oops, sorry for that mess. So this is the first, second, and now we're gonna do the third. So plus, um, we have 3 minus 1 is our z minus 3 minus t. That's awful. I didn't realize it was that awful. Okay, 3 minus t. So what we have, the uh, the lower bound, which is 0, because the last one, as you remember, let's go back there. The last one is 0 here, right? So we have 0 function there. So 0 um, minus 3 minus t u t minus 3. Okay? So now we could simplify this, and let me fix this. We could simplify this and make it negative 3 plus 4 u t minus 3. And like we've been doing, we could flip this around and make it this. So it matches our standard formula. Like I said, it's easier to do it, and this is the a value. So now we're done because we got all of them, all of the three. So let's just find the Laplace transform now. So we look at the Laplace transform. It says Laplace transform of g of t of u t minus a um, of s is equal to e a s the Laplace transform of g t plus a s. Okay, I'm gonna do the first one for you. So the first one we solved, I could scroll back up. The first one we solved is 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 this. So looking at the formula, we could do the first Laplace transform. So the Laplace transform of the first one is t minus 1 u t minus 1. Well, looking at it, let me use different color, that's easier. So this is the g of t, and this, or this value in fact, is the a value. A value. So, looking at the formula, it's hard to see it. Looking at the formula, you just plug this in. You get negative e, what's the a? Negative 1, okay, s, the Laplace transform of g t plus a, right? So this is g of t, correct? So g of t will be, so the t value, g of t is this, and the t value is what we have here in the formula. So here, so in the formula it says t plus a, so t plus a, so t minus 1. So you're subbing this function inside the t plus an a. What is ours a? A we said is 1. Okay. As you could see, the a cancels. So these cancel out. Let me do a different color so it doesn't get mixed up. So these two cancel out. And for the first one is, this is the Laplace transform of t. So what is the Laplace transform of t? It is, we know that the Laplace transform is ni over Sn plus 1. So here, the Laplace transform will be simply 1 over S squared, correct? So 1 over S squared times by E negative S. So this is the first one. Actually, I ran out of space. This is the first one. So now you could do the rest, and I'm gonna write the Laplace transform of the rest one. Okay, now the Laplace transform of all of them after you do it, it should be really simple after this step because it's straightforward. They cancel each other and they end up really nice. So after all this work, you see it at the end at least the Laplace transform are not even that difficult. But setting this up is the most difficult thing. So this is we already solved. I showed how to do it, and the rest will be um, 2, actually this is a negative, should be. So minus 2e negative 2 s, I used y accidentally, over s squared e negative 3s over s squared. Now you could factor, because all the denominator are the same, so you could put it on the same denominator, and you could say e negative s minus 2e negative 2s plus e negative 3s. Okay, I guess we solved the problem. It was, see, like I said, the problem is the setting up this is the hardest. So when you set it up, the Laplace transfer is not even difficult. Um, Setting this up is the limits. So again, if you want to review, first we set this up, and then we set up the boundaries, and we know that the boundaries we go the second function and then minus the other function. So that should be do it. And if you have any questions, please let me know. And thank you for watching.